Hello everyone. In this video we want to focus more on the rate of reaction and how the rate of reaction can be changed, and we want to focus more about the factor that affect the rate of reaction. To understand this, first I want to show you this example as you see here in this figure. If you want to measure the rate of reaction during the time, how it will change during as the time is proceeding. For example, you have, this is the balance as you see here, and you have here a flask, and you put in this flask chemicals like you want to react carbonate, you want to add carbonate and hydrochloric acid. If you want to react these two substances together, one of the product is carbon dioxide. So what's gonna happen to the carbon dioxide by the time? It will go and escape from the flask, right? It start to escape from the flask. As you know, at the beginning, imagine you have started before you put before the reaction, you started with a weight 78 point. Let's say 92 as it's shown in the figure, okay, grams. After the reaction is started, and by the time you will start to see this carbon dioxide, it will go out of the carbon dioxide are given off at the start of the reaction. So the reaction continue, fewer and fewer bubbles will be released then, right? Till all the reaction is stopped, okay? So as the carbon dioxide is lost from the flask, the mass of the flask and the content it will be decreased here, right? If you measure, for example, the mass of the flask every 30 seconds, start to put a table, for example, and every 30 seconds you started to measure the mass or look at the balance, you will find it will the mass it will decrease because the carbon dioxide it will escape from this flask, okay? How can we study the rate of reaction? By looking at graphs. If I have a graph like this is shown here in this page, how can I use these graphs to study the rate of reaction? Let's look at this graph here. In this graph here, if there is any reaction, let's say here the graph can be used to measure the rate of reaction of any given time. Okay, so as you see here, the slope or gradient of the line tells you how quickly the reaction is taken place. Okay, here I want in this reaction I want to measure the mass of carbon dioxide are produced, and here this is the time on the y-axis. As you see here in the y-axis, as I measured the mass of the carbon dioxide. Here is the time. By the time I'm going to measure what is the mass of carbon dioxide. If I want to study this graph here, it's the same here, the reaction between calcium carbonate and hydrochloric acid. Okay, here how the reaction it worked. Look at the beginning of the at the beginning of the reaction. As you see here, the steeper the slope, the faster the reaction. As the slope is steeper, that means the reaction is gonna be faster. Where can you see it is the fastest here? As I see from the beginning here, from when to start till this point, it was what the fastest, because here till this point, from this time to this time, it was what the fastest. Okay, because it's more steeper as you see here. Okay, the line is steepest at the start of the reaction. As you see, if you want to describe this graph, you can tell is steepest at the start of the reaction, because at the beginning of this reaction you will see a lot of carbon dioxide bubbles are produced. Okay, so the line is steepest, as we said, at the start of the reaction, and this is when the reaction is fastest. So as the slope of the line becomes less steeper, less. Here start to slow down, the reaction start to slowing down. That when the line level out, it shows that no more carbon dioxide is being lost. No, that means here when the reaction start to make like straight line here, which means at this time here what the reaction has been stopped, no more carbon dioxide are produced. It's very important to be able to use like this graph. I'll give you sometimes here numbers, maybe in the exam I'll give you numbers. You have to tell me from which time to which time it was the fastest, from which time to which time the reaction start to slow down, at which time the reaction stopped. You have to look at exactly when it start to be what to straight out here, like being and this one here, this levels out, so it means the reaction, it has been stopped here. It's very important to be able to use these graphs to discuss the rate of reaction. Let's continue here. We want to talk about when the rate of reaction, why the rate of reaction is changed by the time. If I want to understand this, let's study the same reaction which is between hydrochloric acid and the calcium carbonate. At the beginning of the reaction, why it was the fastest and the slope it was steeper at that time? Actually, which means here for a chemical reaction to take place, the particles of a reactant involved have to collide. The particles of hydrochloric acid, they will start to collide with the calcium carbonate. These are the reactant. So with each other, as you know, so with enough energy to react them together. So at start of the reaction, there are lots of particles, all of particles, they didn't react yet, they are colliding, so you have, and they are not reacted yet, so collision happened frequently. This means that a lot of carbon dioxide formed at the beginning. Okay, a lot of collision will happen. So as the particles react, what's going to happen to the particles of reactants? So the number that have not reacted gets lower and lower. So the reaction, it start to be what is slower by the time. So as the particles react, the number that have not reacted gets lower and lower. So the chance of two unreacted particles colliding with each other decreases, which means here less carbon dioxide is formed here and slow down. At the end, eventually, all the particles have reacted. There are no more collisions that results in the production of what? Of carbon dioxide gas. Okay, so the reaction has finished. I hope this one is useful to understand the explanation of why does the rate of reaction change. So the rate of reaction changed with the time, which is very important to know this. The slope of the graph of the result is a measure of the rate of reaction. So the more collision between particles of reactant there are in given a time, the faster the reaction. So this is about the change in the rate of the reaction by the time, how it changed. Okay, if you still have a question about the change of the rate of reaction, you can send me your question. Thank you for listening.